Patterns and Equations, Topic 15-2, Envision Math 6. Previously, we've looked at equations and created tables. Now we're actually going to look at a table and create an equation. So how can you find a pattern to write and solve an equation? Well, we're going to look at table 1 and we'll get some information from the table. In our table, we have our ordered pairs, where x is 0, y is 0, where x is 1, y is 3, where x is 2, y is 6, and where x is 3, y is 9. First, we're going to look at where x is 0. Does y equal 0 too? Yes. Then the equation must involve multiplication or division. And if we think about that, it makes sense. Because if x is 0, if I multiply it by anything, it will still equal 0. Or if I divide it by anything, it will still equal 0. Second, we're going to see if we can describe the pattern. We want to know what is happening to x to equal y. Well, if I look at that, I can say, to change a 1 into a 2, we know it's multiplication or division, so I would have to be multiplying by 3. To change 2 into 6, I would have to be multiplying by 3. And to change 3 into 9, I would have to be multiplying by 3. Do I see an answer here? Yes, x is being multiplied by 3. Third, I'm going to check it. Does the rule work for every xy pair? So let's see, if my rule is 3 times x equals y, I could say, let's see, 0 times 3 equals 0. So yes, it works for that row. Then 3 times 1, it equals 3, so it works for that row. 3 times 2 equals 6, it works for that row. And 3 times 3 equals 9. So yes, my rule works for every xy pair. Here's our second table. We're going to look at this table and get some information from it. Let's see what we can conclude. First, we're going to look at where x equals 0. Does y equal 0 too? In this case, no. So that means the equation must involve subtraction or addition, because again, if it was multiplying or dividing, then y would also equal 0. Second, we're going to describe the pattern. What is happening to x to equal y? Well, if I look here, from 0 to 2, it looks like they're adding 2. From 1 to 3, adding 2, 2 to 4, adding 2, and it looks to me like I have found a pattern. So that means it is x plus 2. And then third, we are going to check it. We want to see if the rule works for every x plus y. So we'll write our rule as an equation, which is x plus 2 equals y. So let's see. If I take 0 and I add 2, it equals 2. It works for that row. 1 plus 2 equals 3, works for the second row. 2 plus 2 equals 4, works for the third row, and so on. I have found my equation. All right, we're going to look at this third table. It starts to get a little tricky when we have a two-step equation. It's actually going to be more difficult to find the pattern and to write the equation. So let's see what we can conclude. First off, we're going to look again at where x equals 0. Does y equal 0? Well, if we look at both of those, I can say no. That means it must involve subtraction or addition, because if it were just multiplication or division, y would also be 0. So let's look at the pattern itself. What's happening to x to equal y? Well, let's see. To make 0 to 2, it looks like that is adding 2. 1 to 5 looks like they're adding 4. 2 to 8, we're adding 6, and 3 to 11, we're adding 8. So I don't know actually. I do not see a pattern yet. So that means I'm going to go back over here and look at where x is 0. I can tell by that point right there that 2 was added. So that is part of my equation. Something's happening to x, and then they're adding 2 to equal y. So now I'm going to use inverse operations to see what the table looked like before 2 was added to each x. Inverse operation means I'm going to subtract 2. So I'm going to look at the y values. 2 minus 2 gives me 0. 5 minus 2 gives me 3. 8 minus 2 is 6. And 11 minus 2 is 9. Now I can kind of ignore that middle column and just say, okay, to make 1 equal 3, that would be multiplying by 3. To make 2 equal 6, that would multiply by 3. To make 3 equal 9, that would multiply by 3. So now do I see a pattern? Actually, yes, I do. Now I see it looks like x is being multiplied by 3. Then we are adding 2 to it to equal y. So third, we are going to do our check step, and we want to see, does the rule work for every xy? So let's see. If I take 0 and multiply it by 3 and add 2, that gives me 2. So it works there. If I take 1 times 3, that gives me 3, plus 2 is 5. It works for that second row. Now if I take 2 times 3, that's 6 plus 2. That equals 8. Yeah, worked for that row. And then if I take 3 times 3, that's 9 plus 2. That equaled 11. So yes, it works for that row too. I have a successful equation. Now I know this can be a little bit confusing, and I've struggled over the years on trying to help students figure out what the rule is if they can't just look at it and automatically see it. So I've come up with this flow chart here. First we're going to say, where x equals 0 does y equal 0? If the answer is yes, we follow over here on the left-hand side and say, that means multiplication or division is involved. If we say no, we follow to the right-hand side and say, oh, that means addition or subtraction is involved. Now I look and I say, do I see a pattern? If the answer is yes on either one of those, great, I'm done. It's a one-step equation. I describe the pattern, meaning I write the equation and I'm done. If I'm over here on the multiplication or division side and I say no, then I go, oops, I made a mistake, and I have to assume that it is addition or subtraction also involved. If I've done the addition or subtraction and I don't see a pattern, then that means, okay, now I need to use those inverse operations to make a new y column, and then I'm going to look to see if I have a pattern. And then I can follow over here again. So we're going to use this chart to try to find an equation. Okay, so for this fourth table, we're going to get some information. We're going to look at the table and see what we can conclude. So we're going to start at the top of our flow chart. Where x equals 0, does y equal 0? So I look here, where x equals 0, y equals -3. So the answer is no, which means it doesn't involve just multiplication and division. We've got subtraction or addition going on. So since my answer is no, I come down here and I say, okay, now, do I see a pattern? Well, to go from 0 to -3, it looks like they subtracted 3. 3 to 0, they subtracted 3. 6 to 3, subtracted 3. 9 to 6, subtracted 3. So it looks like what's happening to x to equal y, meaning means that they're taking x minus 3 to equal y. So now I'm going to check, does the rule work for every xy? Well, if we use substitution, I take 0, substitute it for x, and 0 minus 3 would equal minus 3. So it works for that row. Now I'm going to substitute 3 for x. 3 minus 3 equals 0, works for that row. 6 minus 3 equals 0, works for that row, and so on. So I can say, yes, the rule works for every xy. I have found my equation. Okay, here's the fifth table. You can try this on your own, or you can just follow it along with the video. If you choose to try it on your own, go ahead and hit pause, and when you hit play again, the answers will appear. So we will start at the top of our chart here, and we were going to say, okay, where x equals 0, does y equal 0? If I look at that row on my table, I can say nope. So I follow over here, and that means addition or subtraction have to be involved. So now I need to see, can I describe a pattern? Well, it looks like here I would be adding 3. Second row, adding 2, adding 1, and adding 0. So, do I see a pattern? I'm going to follow over here and say no. So that means I need to use inverse operations to make a new y column. Okay, so if I look at this first column here, where x is 0, I can see that 0 plus 3 would equal 3. So I'm going to do the inverse. The opposite of adding 3 would be subtracting 3. So I'm going to subtract 3 from each y value. 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2, 6 minus 3 is 3. So now I'm going to go back and say, now do I see a pattern? And this time, that y is 0. So now I've got a 0 for the x, a 0 for the y, so I'm looking for something involving multiplication or division. So to make 2 equal 1, since that's getting smaller, 2 divided by 2 would equal 1, so I think that would work. Let's see, to make 4 equal 2, 4 divided by 2 equals 2, and 6 divided by 2 equals 3. So that tells me for this equation that first x is being divided by 2, and then we had that second part where it added 3 to equal y. So what is happening to x to equal y? We're saying it's being divided by 2, then we add 3. Now we just have to check and see if the rule works for every xy. We're going to use substitution and look at our original values, the 3, 4, 5, and 6 in the y column. So if I substitute x for 0, 0 divided by 2 is 0, plus 3, that does equal 3. So that checks right there. Next, let's see, 2 divided by 2 is 1, plus 3 is 4. Oh, that checks. 4 divided by 2 is 2, plus 3 would be 5. That checks. And 6 divided by 2 is 3, plus 3 will give me 6. So yes, it looks like I have found a rule that works for every xy. Now go ahead and do your quick check and see how well you understood today's lesson.